Now, we want to solve this integral, which is the integral of x plus 2 over x squared plus x dx. Note, this is a rational function, so we're going to use this note to figure out how we're going to integrate this. Note in here that the degree on the numerator is less than the degree in the denominator, therefore we will not use the long division. So first, to use partial fractions, we have to simplify this term in here. So first, to use the partial fraction, the denominator has to be simplified. The integrand is x plus 2 over x squared plus x. The denominator can be factored as x, and then we will have x plus 1. Now, we can use partial fraction. Here, note that these are two linear distinct factors. Therefore, we're going to use this point in here. So to use the partial fraction, it's going to be in form of this. So this is going to be equal to a and then over x and then plus b over x plus 1. So this is what we are going to work with. First, we have to find what is a and then what is b. First, I'm going to multiply both sides by this denominator. The left side going to be equal to just x plus 2. Then on the right side, it's going to be a multiplied by x, and then x plus 1, and over its denominator, and then plus b multiplied by x, then x plus 1 over its denominator, x plus 1. Now we can simplify. Notice this x can go with this x, and then this x plus 1 can go with this x plus 1. Now this can be written as x plus 2 equal to a, and then x plus 1, plus and then b multiplied by x. Again, we want to solve for a and b. So to solve for a, I'm going to equal x to 0. So in the left side going to be 0 plus 2, and then on the right side going to be a, and then 0 plus 1, and then plus b multiplied by 0. This term will go, and then we are left with 2 equal to a. Now, to find b, I'm going to set x equal to minus 1. So we're going to have minus 1 plus 2 and then equal to a multiplied by minus 1 plus 1 and plus b multiplied by minus 1. This is going to be equal to 1, and that's going to be equal to minus 1 plus 1, that's going to be equal to 0, and left with minus b. Therefore, b going to be equal to minus 1. Now, I'm going to plug this value back into here. So, x plus 2 over x multiplied by x plus 1 equal to a, which is 2, then over x, then plus, and then b, it's going to be minus 1, and over its denominator, which is x plus 1. Now we are ready to integrate. So the integral on the left side is going to be the integral of the right side. That's going to be equal to the integral of 2 over x dx plus the integral of minus 1 over x plus 1 and then dx. Now the next step is to pull this constant out. So it's going to be 2 multiplied by the integral of 1 over x dx, and then minus, which is just minus 1, multiplied by the integral of 1 over x plus 1 dx. Note this integral in here. This is the integral of 1 over x plus 1 dx. This can be solved using substitution, and that's going to be equal to natural log of the absolute value of the denominator, which is x plus 1. We'll see. So now let's go back to find the antiderivative. It's going to be 2. And then the antiderivative of 1 over x is just natural log of the absolute value of x. And then minus sign, and then the antiderivative of this integral is going to be natural log of the absolute value of x plus 1 and plus c. And that should be the antiderivative of the integral. Again, note in here that this integral can be solved using the table of integration.